Hello everyone, welcome to the second lecture of ITE 1222 System Analysis and Design course. My name is Dr. Gaishan Amarasinghe. In this lecture, we are going to talk about system development methods. We use a standard color coding scheme to make it easy for you to find the important points in these slides. So please take a moment to learn this color coding. As you may remember from the introduction to this course, there are many different types of systems that can range from simple systems such as a calculator to a complex system such as the World Wide Web. Because of that, designing systems can be a complex and overwhelming task. So as for solving any complex problem, we should follow a methodic approach to solving the problem of designing systems as well. Such an approach can guide us from the inception to the completion of the project. Software Development Lifecycle, or SDLC for short, is such a methodology that can help the whole team to manage the development effort of a software-based system. Let's look at what is SDLC and how we can utilize this methodology as a tool in system analysis and design. Software Development Lifecycle is a methodology which consists of a series of steps that aims at producing software with the highest quality. SDLC comprises of a comprehensive plan for the development and the maintenance of an information system. Usually, SDLC includes several distinct stages including analyzing, designing, building, testing, and deployment. Waterfall model, spiral model, and agile model are some of the examples of commonly used SDLC models. Software development lifecycle is a sequence of steps which presents a general perception of the entire software development process. It starts with an understanding of how the software will be implemented from the business requirements. There is no such one unique SDLC model that can be applied to every scenario. Thus far, a collection of SDLC models have been introduced and are being used in the industry in various contexts. These models are also referred to as software development process models. Each process model accompanies a sequence of steps to guarantee the success in the entire software development process. A good software engineer should have adequate knowledge on how to choose the SDLC model based on the project context and the business requirements. The SDLC model typically includes 5 phases: systems planning, systems analysis, systems design, systems implementation, and systems support. As you can see in this diagram, these phases are cyclic in such a way that you move on to the next phase after completing the current phase, and eventually you may have to get to the first phase. This is a normal behavior in a SDLC. We will look at them one by one next. However, it is important to identify what needs to happen inside each of these phases as well. Any new application development should undergo the following core processes: identifying the problem, planning and monitoring of the project, understanding the features of the problem, designing of the system components, building, testing and integrating system components, and finally deploying the system. There can be minor variations to the way these core processes are executed. These variations occur based on the way each process is planned and how such processes are integrated into a project. It is important to note that the 5 main phases of the SDLC is defined to facilitate the above mentioned 6 processes. Now, we will try to understand the 5 phases in SDLC. The systems planning phase commences with a request for a new system. The person or the entity that made the request may describe difficulties or decide alterations in an existing information system or a business process. Or it may also be about a completely new requirement that is not fulfilled by the existing system or processes. In many organizations, systems planning is an integral part of their overall business. The request can be notable or comparatively insignificant. A major request would require an entirely new information system or the upgrading of an existing system. On the other hand, a minor request would demand a new feature to the existing system or several modifications in the interface. This phase involves carrying out a preliminary investigation to evaluate an IT cognate business opportunity, so you prioritize the requests based on the business goals. This preliminary study is a deciding step because the outcome of that study will affect the entire development process. A key part of the preliminary study is a feasibility study that reviews anticipated costs and benefits and recommends a course of action predicted on operational, technical, economic, and time factors. Assume you are a system analyst and you receive a request to implement a new mobile application for the procurement management system being used by the organization. In such a situation, your primary action is to decide whether it makes sense to originate a preliminary investigation at all. If you decide that a preliminary investigation is necessary, then you will have to conduct a feasibility study to see whether it is feasible to implement this request. If the development process continues based on the outcomes of the system's planning phase, the next step is the system analysis phase. The idea of the system analysis phase is to build a logical model of the proposed information system. It starts with the requirements modeling, where all the business processes are identified and documented. In this phase, we need to learn about the requirements and if an existing system is there, about the existing system as well. To learn the system, it is important to carry out a comprehensive fact-finding by using techniques such as interviews, surveys, document review, observation, and sampling. We need to gather information from all the stakeholders both within the organization as well as outside the organization if applicable. The result of fact-finding are used to build data and process models and object models which will be the logical model of the proposed system. After a complete system analysis has been conducted and all the information has been gathered to build the logical model of the proposed solution, we can move on to the system design phase. The objective of the system design phase is to build a physical model that will fulfill the requirements of the proposed system. This phase is responsible for identifying the inputs, identifying the outputs, identifying the processes, as well as designing the user interfaces. Moreover, the design phase involves determining the application architecture that will be used by programmers to convert the logical design into the programming modules and code effectively. The outcome of this phase is known as the System Design Specification or the SDS that will be handed over to the management and users for their approval. The involvement of the management and users is important to get rid of the misunderstandings about what the new system will do and how it will do it. Once the SDS has been formed and has been approved by the stakeholders, we can move to the system implementation phase. The system construction takes place during the system implementation phase. If the system is developed by the developers in-house or by an outsourced organization, different development methodologies may be applicable in this phase, such as structured or object-oriented programming principles. Despite the applied methodology, during this phase, software programs are written, tested, and finally, the system needs to be deployed. In case if the system was purchased, the responsibility of the systems analyst is to configure the software and to execute any required alterations. A fully functioning information system with the required documentation will be produced as the output of this phase. However, it requires several final arrangements such as switching data to the new deployment environment such as a cloud solution and performing the real migration of users to the new environment and the system. Once the implementation has concluded and the solution has been deployed, the next phase is the system support phase. System support phase includes maintenance activities, possible enhancements, and system protection. An example of a maintenance activity could be resolving minor errors, such as fixing a bug in the user interface. In contrast, enhancements provide new features and benefits. For example, adding a new OAuth-based login to the system could be an enhancement done during this phase. Upgrading a used software library to apply a security patch can be considered as a system protection activity. The recently exposed Log4j vulnerability and fixing that vulnerability can be a good example for this scenario. Due to the rapid changes that are done to software systems, majority of the information systems need to be updated significantly or replaced after several years of operation. As a result, you may have to move to another cycle of system planning at the end of system support phase. Otherwise, the next phase will be the retirement of the system. There are numerous SDLC models established and devised that are being followed during the software development process. These models are widely known as software process models. One can imagine of SDLC models as tools that are essential to ensure the smooth delivery of a high-quality software system. Accordingly, understanding of the pros and cons of each model is essential for software engineers to pick the best process model to fit into the context of the project. We will discuss process models in detail in software engineering course module. However, during this week, we will briefly explain the steps of the traditional waterfall model and its steps. However, it is important to note that the traditional waterfall method may not be the best or the most appropriate method for complex systems development. Other incremental and or iterative development models may be more appropriate for some projects. The waterfall model is known as the most historical SDLC approach for software development. The waterfall model is also referred to as a linear sequential model as well. This model is straightforward to understand and use. The underlying concept of waterfall model is that each phase must be completed prior to beginning of the next phase. As a result, overlapping is not possible among the phases of this model. From a practical perspective, the waterfall model is not appropriate for complex software systems due to this. However, for smaller projects, it may be utilized to produce solutions. The figure illustrates the major steps in this waterfall model. Requirements phase, which is the first phase of the waterfall model, requires knowing the functionalities of the software system to be developed. Therefore, all potential requirements are obtained in this phase and placed in a document called Software Requirement Specification or the SRS document. System design phase starts by analyzing the SRS document prepared in the previous phase. System design assists in specifying both hardware and system requirements which would lead to designing the overall system architecture. The implementation phase is based on the inputs received from the design phase. The programming job starts in this phase. It starts by writing small programs known as units. Each unit is then tested for its correct functionality. This process is called as unit testing, which is very important in this process. In the integration and testing phase, all tested units are integrated. A complete software testing procedure is required to ensure no bugs and vulnerabilities found in the software system. After the testing phase, the product will be deployed in the client environment or it will be released to the market. Main purpose of the operational and maintenance phase is to modify and update software systems after delivery to resolve bugs and to enhance performance. The software can be considered as a model of the real world. Consequently, the software needs modifications when the real world changes. Additionally, change requests from the clients are also addressed during this phase. So now that you know about the waterfall model, as an activity, see if you can map the phases in the waterfall model with the 5 phases of the SDLC. In this lecture, we discussed about the system development methods with the help of the software development lifecycle, which provides a methodic approach to systems development. The 5 phases: systems planning, system analysis, system design, system implementation, and system support guides a system analyst to design and develop such systems. Software process models such as the waterfall model or the agile development model, which you will learn later, can be used as tools to deliver these software-based systems as solutions to the problems. It is vital to note that it is the responsibility of the software engineering team to select the appropriate tool for the project depending on the context, requirements, the stakeholders, and other aspects of the project. That brings us to the end of this lecture on system development methods. Let's meet again on the next lecture. Thank you.